Good morning everyone. My name is Suhail Ahmed. My registration number is 19110. I am from Triple E department. Today we are going to discuss about op-amp for wave shaping and square wave generation. First we are going to see about clipper. A clipper is an electronic circuit that produces an output by removing a part of the input above or below a reference value. Here there are two types of clipper, positive clipper and negative clipper. Before we are going to see about a clipper, you have to know about precision rectifier. Precision rectifier is nothing but able to clip the waveform at particular level. This clipper circuit is also known as precision clipper circuit. On seeing this two circuit, whenever the diode is on, that is forward bias, the diode will act as a short circuit or closed circuit. Whenever the diode is in off or reverse bias condition, the diode will act as a open circuit. Here the diode is connected in feedback path. Whenever the diode is on condition, it will act as a short circuit and it acts as a closed loop configuration, and its circuit looks like a voltage follower, that is output follows the input. And there is another important point, that there is no voltage drop across the diode because of the high gain of op-amp. Here I also proved that Vf dash equal to Vf by AOL equal to 0.7 is the forward voltage drop of the diode divided by high gain of op-amp, that is open loop gain of op-amp 10 per 5. When we divide this, we get the 0 voltage, that is there's no voltage drop across the diode. Active clipper circuit. We will see the working of circuit by applying sine wave as input to the following circuit. For taking a positive V reference, when the condition Vi is less than V reference, the output of op-amp will go into the negative saturation. Whenever it goes into negative saturation, when negative is connected to the cathode of the diode, it will become the forward bias, and the diode will conduct and it becomes a short circuit, and it will act as a closed loop configuration and becomes a voltage follower, and the output will be equal to input. The output follows the input. Here you can see when Vi is less than Vref, the output diode is on and the output follows the input. The same when Vi is greater than V reference, the output of the op-amp go into the positive saturation. Whenever it go into the positive saturation, positive is whenever the positive is connected to the cathode, it becomes a reverse bias. Diode will off and it become open circuit, and the output will be equal to the reference voltage. Here the output will be equal to the reference voltage whenever Vi is greater than Vref. For the same circuit, we can find out the output waveform for negative reference voltage. For the condition Vi is greater than minus Vref, the diode will act as a open circuit because the output of the op-amp with positive saturation will come as a positive saturation. When positive is connected to the cathode of the diode, it will become off, so that it will act as in a reverse bias condition. For Vi less than minus Vref, the diode will conduct because of the negative saturation. Whenever the negative saturation is connected to the cathode, the diode will conduct, and when diode will conduct that and it acts as a voltage follower, and the output will be equal to input. Here you can see the output of the waveform. Whenever the Vi is less than Vref, this condition, the output follow the input, because in this condition only diode is on. Whenever Vi is greater than Vref, the diode is off, so the output follows a reference voltage. For the same, we can reverse the direction of diode to get a negative clipper circuit. For negative reference voltage, when the condition Vi is greater than minus V reference, the op-amp will go into the positive saturation. And then whenever the op-amp go into positive saturation, when the positive is connected to the anode of the diode, the diode become forward bias. The forward bias need conduct and it acts as a voltage follower, and the output is equal to the input. Whenever Vi is greater than Vref, minus Vref, minus of Vref, here the output is equal to the input. You can see that the output is equal to the input. At the same time, when we see that V in is less than minus Vref, diode will become off because of the negative saturation. Whenever the negative is connected to the anode of the diode, diode become off and become open circuit, and the output will be equal to the reference voltage. Whenever vi is less than minus vref, the output, the diode is off, the output is equal to the reference voltage. What are the reference voltage? That is equal to the output. For same circuit but with positive reference voltage. When vi is less than vref, op-amp will go in negative saturation because of diode is an off condition, as I told earlier, and the output will be equal to the reference voltage. When vi is greater than vref, the op-amp will go into positive saturation, and positive is connected to the anode, and diode will on, and the output follows the input. You can see that when vi is greater than vref, diode is on, so that it follows the output. When vi is less than vref, diode is in off condition, so that it equal to the reference voltage. Clamper. The clamper is also known as DC inserter or restorer. The circuit is used to add a desired DC level to the output voltage. In other words, the output is clamped to a desired DC level. There are two types of clamper. Positive clamper if the clamp DC level is positive, negative clamper if the clamp DC level is negative. First we are going to see about positive clamper. I am going to explain this under three circumstances. In the circuit, that diode, resistor and capacitors are present. First circumstance, we have to assume that there is no input sine wave supplied, so the output voltage at inverter terminal will be 0 voltage, so the output voltage will be V reference, because because of there is no sine wave, is inverting terminal will be 0, only the positive V reference will be present. Because of positive applied to the anode of the diode, it will be conduct, and output will come as a V reference. Because of there is no input, there is no voltage, capacitor will also not hold any charge, so that voltage at a capacitor also 0. Second, we have to assume the sine wave is given as an input for peak voltage of 3 voltage at the inverting terminal. For the sake of simplicity, I take as a negative half cycle of Vi, and diode will conduct and charge the capacitor through the diode to the negative peak voltage up to Vm. How it conduct, I can elaborate. Whenever we take a negative half cycle, negative voltage is present and you get positive. The difference between those two is Vref minus of minus will give us positive value. So positive is connected, when positive is connected to the anode, it will conduct, so it will conduct, and it charge the capacitor to in this way up to the peak voltage of Vm, negative peak voltage of Vm. This then we have to consider the positive cycle of Vi. When positive cycle Vi, the diode D is reverse bias and the capacitor will retain its previous voltage Vm. Whatever we store during the negative cycle will be retained during the positive cycle. So since the voltage Vm is in series with the AC input signal, this two is in series, so during positive cycle this two will be come out as a voltage. Therefore total voltage drop is equal to V reference plus Vi plus Vm. Here you can see the output waveform. The output is clamped up to the DC desired level up to 2 Vm, and I also draw the waveform with Vm equal to 3 voltage, V reference equal to 1 voltage, and 2 are constant, and by varying the V input as minus 3 volt to plus 3 volt. Here I get the waveform as a clamped DC level. Negative clamper achieved by reversing the diode. You can see that reversing the diode. Here also I am going to undergoing 3 circumstances. We have to assume same that we have followed in positive clamper. There is no input sine wave. Then the voltage at inverting is 0, and minus V reference will appear in the output of the op-amp. When there is no input voltage, capacitor will also not hold any charge, so the voltage at the capacitor also 0. Now we have to assume that sine wave is given at the input for the peak voltage of 3 voltage at inverting terminal. Here for the sake of simplicity, I am taking the positive half cycle for the negative clamper, positive half cycle of the input. Consider positive half cycle, diode will conduct and capacitor charges through diode to the diode D to the positive peak voltage. How it conducts, I will explain that. Whenever the positive half cycle, it become positive at the inverter terminal, we are assuming minus V reference. The difference between two is minus of Vi, that is Vi plus Vi. So the output will be in my negative. Whenever the output is negative, when the negative is connected as and to the cathode, a diode will conduct and it will charge the capacitor to this way, and it store the peak voltage up to the Vm. Then I again to consider negative half cycle away. During negative, the diode is reverse bias and capacitor will retain its previous voltage Vm. Whatever we store during the positive cycle, will retain its voltage during the negative half cycle. So since the voltage Vm is in series with the input signal, then the output will be equal to Vi plus Vm, and therefore the total output is equal to minus Vref plus Vi plus minus of Vm. Here the output voltage, output waveform, we can see that it is clamped up to the DC side level on the negative side. I can say up to 2 Vm in this circuit, but I have drawn using the given value as assuming that value as Vi is equal to minus 3 to plus 3, Vm is equal to minus 3, and Vref is equal to minus 1 volt. When I apply this, we can get the waveform as a right side image. Application of wave shaping circuit. Wave shaping circuits are commonly used in diesel communications such as TV and FM receiver. Wave generation. Using comparator, we can generate different square wave with different duty cycle by varying the reference voltage. Comparator just compare the given input with reference voltage and gives the output. Here I am going to give the triangle waves input to the non-inverting comparator with some reference voltage. Before that, we have to know about the basic about comparator. For non-inverting comparator, when Vin is greater than V reference, output will be high. When Vin is less than V reference, output will be low. For inverting comparator, Vin is higher than V reference, output will be low. When Vin is less than V reference, output will be high. By keeping the V reference equal to 0 for triangle wave, I give a triangle wave as an input to the non-inverting comparator. When the non-inverting comparator will be high when Vin is greater than Vref. Above Vin is greater than Vref. Here I will mark as fully Vin is greater than Vref. So the total time period will be on. So we will get the square wave output. By keeping V reference less than 0, we also get the square wave with more than 50% of duty cycle. And then keeping V reference is less than 0, you can get the output as square wave with 25% of duty cycle. By giving triangulars as input to the inverting comparator with some specific voltage reference voltage, when Vin is less than Vref, we get the output as high, so we get the output as square wave. We can also generate using as a stable multivibrator. Initially, we have to assume that a voltage across circuit is equal to a positive saturation. The capacitor will charge in this path. I will show that in this path, and also in this circuit, in this waveform, the capacitor charging through this way. When the voltage reaches the upper threshold voltage or beta V stat, then the voltage at inverter terminal is greater than the voltage at non-inverter terminal. Then the output of the op-amp will switch from positive saturation to a negative saturation, from this to this, and the capacitor charge in the reverse direction, that is in this direction. As soon as the voltage just go below the minus beta sat, then the V minus is less than V plus, the output switches from negative saturation to positive saturation, but this from this. in this way. By charging and discharging a capacitor, we get the square waves at output. Thank you.